Hey guys, welcome back to my YouTube channel. So today we are going to discuss problem path to given node. So it's very easy problem. Let's see the problem what the problem is. So in this problem we are given a binary tree containing n nodes. We need to find the path from root to a given node. Okay. So in the note it is given that no two nodes will have the same values, and you can assume that B is present in tree A and a path will always exist. So it means that the node which we have to find, it will always be in the tree. We just need to simply return the path. So let's take this test case and understand it better. Let me just quickly write the test case. 1, 2, 3, 4, 5, 6, 7. So in this value which we have to find is 5. So it is already given in the problem that 5 will always be present in this tree. We just need to return the path. So in the output, if you see, path will be this one. So path will be 1 comma 2 comma 5. So if you see the output, we have in the output 1 to 5. Then the other test case which we have given is that b is equal to 1. So if we take b is equal to 1, 1 is root only itself. So there will be only one element in the list, which is the root itself. Okay. So I hope you understood the problem. Just pause the video and try to approach it. So I hope you might have tried. Let's quickly see how we can approach this problem. So we have this tree 1, 2, 3. Okay, and B is 5. So whenever we have tree problem, right, we always have to visualize it somewhat like this, that we have root. Okay, we have the left subchild. Basically we have the left subtree and we have the right subtree. Okay, so we will do work on this node. We will do our work on this, and we will recursively ask we will ask recursion to give the result from left child, and we will ask recursion to give the result from the right child. Okay, so now suppose that uh, 1 is your root, right? Let's say you are here, you are initially at root, and you will just simply ask from recursion that, okay recursion, I will pass you the left child of root. Okay, you will pass root dot left, and you will just ask from recursion that if 5 is present in the left subtree, just simply return me the path. So you will assume that recursion will provide you the path. So recursion will give you 2 comma 5, because if you see in the left subtree, this tree, the path it will be leading to 5 will be 2 and 5. Okay, so this will be your result from left, and from right, recursion will also call on the right subtree, because it might happen that on the right side you will have this value. So as of now here we do not have 5 in here, so from the right child you will get empty. Okay, so now once you get the result, now it's your responsibility to add the root in this list, because you will be having this root also in the path, right? So your path will be 1, 2 and 5, basically this 2, 5, and you will have to have 1 here in the starting of this. So basically this will be your path. So this was basically like the approach. Let's quickly dry run now how I have written the code for this. 2, 3, 4, 5, 6 and 7. Okay, so what will happen? We will first of all, like, what will be the base case? Let's discuss first what could be the base case. Let's say you have an empty tree. Let's say you have an empty tree. So in that case, if you have to find, let's say b is equal to 5 in it, since there is no node in this tree, the output will be an empty list, right? Output will be an empty list. So your uh, your base case can be that if your root is null, meaning there is empty tree, okay, then simply return false, because there cannot be path. Okay, so I will have a function, helper function, in order to just this helper function will tell whether the path is there or not. Path is there or not. And I will have an array where I will be maintaining the path. Like whatever path is being formed as of now, I will just have it in this array. So this array will be having the path leading to the B node which we want to find. Okay, so let's start from the root node. Let's say one we have initially in the root. This is root. So this root value will be added in this list. Okay, so first step is add root in the list. So we will just simply, let's say this list is L, or you can name it as path. Okay, let's say this is path. So path dot add, you will do root dot value. Okay, this is the first step. Now after that you will move to the left child. So let's say I move to 2. So my root will now become 2. Okay, so this is recursion. Okay, so we are now here. So from this 2, what we will do, we will just basically add this in. So step is so what we do basically, we just add in the path list and we move to the left child. Okay, so this is what we have done here. Now we are at 2, so we will add 2 in this list and we will move to the left child. So now this root will now be here at 4. Okay, so now you will add 4 here. Okay, you will add 4 here and you will now move to the left child of 4. So 4's left child is null, so root becomes null. So now your root becomes null, right? Root becomes null. It means that you haven't found your B node as of now, because if you would have found B node, you might have got your path. So when your root becomes null, it means you didn't got the path, so return false. So we'll just simply return from here. But before returning, right? Before returning, we just need to remove. So this 4. So basically this 4 is not a path, not a part of our path, right? So before going to the parent node again, we have to just exclude this from our list. So I will just pop this from our list. Now again we'll go to 2. So when we go to 2, the next step will be go to the right child. Okay, so I go to the right child. Now from 2, the right child is 5. So now my root is at 5. My root is at 5. Okay, so I'll just simply erase this. Now see, we have to have a check now that if root value has become the value which we have to find the path to. Okay, we have to find path till 5, which is B. So if our value root becomes that, we just simply return true here, that we found our root and we found the path. Simply return true. So 1, 2 and 5 we got. So this is how we'll get our path. Alright, so I hope you understood the problem. Let's quickly see the code. Just dry run once with some other test cases, you'll understand better. So what I have done is I have taken this path list which will store our path, and basically this is a list. After that, since we have to return an array, I have made this array. So whatever path I will get right to the node B, I will just simply store it in this array and return array. I have created this helper function, okay, which is, we are passing the root, we are passing this path, and we are passing B node which we have to find. If root becomes null, it means we didn't got the path, and then we will add the root value in our path. If our root value is B, it means we found the path, we return true. If we do not, if we find path from any of these, just simply return true from there. We will not process further only. Okay, so what does that mean? When you got 5 here, you will simply return true from here. When you come to this 2, your left, from your left you didn't get anything, but from this 2's right recursive call you get true. Okay, so if any of this is true, so here see, if any of this is true, you will just simply return true. So from here you will simply return true. Now from this one we had made the left call, from that we get true. So here if from the left call only itself you get true, so you will just simply return true, you will not even make the right call. So this right call to 3 will never be done, and from here only you will return true to the final here. And your answer, this your answer path array will be storing the final path. Okay, so I hope you understood this problem and the approach. Let's submit it. So it's passing. uh, let's understand the time and space complexity. So time complexity of this problem will be, so see what we are doing, we are just basically going uh, to like basically traversing the tree, right? And it might happen that our basically it might happen that we have to traverse all the nodes of the tree. Like it might happen that your path is like your b node is 7, right? So you have to go to 1 3 7, and for this to happen you have to go to this entire tree first, like this all nodes, right? This node, this node. So o of n will be the time it might happen, right? O of n will be the time complexity, n is number of nodes. And space complexity is obviously like there can be how many recursive calls at a time. So o of h will be the recursive calls at a time. So we have O of h as the space complexity. So I hope you understood the problem and the approach. Let me know in the comments if you have any doubt. You will find the link to this code in the description. And if you found the video helpful, please like it, subscribe to my channel, and I'll see you in the next video. Thank you.